Okay, so number 25 in 20.3 tells me at first I should suppose c is the speed of light. Okay? Sure. That's a symbol that I've seen in a physics book once. It tells me that there's a thin wire along the z-axis. So I drew a thin wire along the z-axis that carries a current I. I have no idea what that means. But I remember that there's something about right-hand rules. I don't know. And then it tells me that it produces a magnetic field, which is B. So there's apparently this magnetic field that's induced by this current, right? Which is like 2I over C. And then there's some nonsense in here about like minus yi plus xj over x squared plus y squared. Maybe square it? No? Okay. Cool. Okay, so what the business is this?
It's a magnetic.
There's a radius on the bottom.
Huh, yeah, the bottom looks like a radius. What does the top look like?
Yeah.
Yeah, that looks like that friggin' spiral thing, right? So if you scale a spiral by the radius,
Unit. I don't know.
That'll tell you that the current comes out.
Makes sense.
So this is the outward spiral.
how about this vector, right, on the top here, is how long?
Is there long? Like,
X squared plus y squared.
Yeah, it's x squared plus y squared long, right?
okay.
So this is probably unit spiraling.
Oh, so it's just a unit.
You guys see that? Like, at least that's what I'm thinking. This bit's probably unit spiraling. What's this thing?
Is current a constant? Like, if I is a
Yeah.
constant, then we just know the entire thing's a constant.
Yeah, so this is proportionality, right? Whatever.
That looks like the magnetic spin in a solenoid.
So this is telling you that if you run a current through this wire,
Yeah.
the magnetic field that it induces is just kind of spiraling around the wire. You guys see that? How do I know it's not going like up or down or something?
There's no Z's.
Yeah, I just got x's and y's, right? Really i's and j's here.
Mm-hmm.
The z component, the k component is 0. You guys with me on that? Okay, so part A. Does the curl of B equal 0?
So
Don't calculate this.
It should.
Yeah, it's not
It should
0.
not equal 0.
How do I know it's not 0?
It's
The last
all
bit.
curls. All curls.
The whole thing is freaking
Because the whole thing's friggin' spinning around, right? And it's spinning in a really consistent direction, right? Right-hand rule in the flow will give you pointed up. You guys see that? So if you stick one of those little pinwheels in here someplace, what's it going to do? And point up. Right? Probably? Should we calculate anyway?
No. Yeah. The first two end up being zeros immediately because they use the.
Let's calculate anyway, because I think my intuition might be betraying me.
Yeah, because I think we did this in the math lab.
Okay, so let's check the curl of B. So I'm going to suppress this constant.
Yep.
Pretty good with that?
Don't need any more anxiety than this.
Okay, so here I should get the, what should this first guy be? That should be the
Y,
z partial
Z,
with respect to y
with
minus
y
the
partial with respect to z.
y partial with respect to z, right? Okay, what's the z component of this business?
0.
0. Okay, what's the
Anything
z partial of the y component?
Anything in respect to z is 0 in this.
Also 0. Cool. Next guy. That's going to be the partial
X to z. So another 0.
zyx Oops, back. That one's going to be 0.
And this is the.
And the partial with respect to x
X
of
Z.
the
Z.
z component.
So it's another 0.
So that one's also 0.
And then we get Green's theorem from the last one, basically.
And then this last thing should be, Green's. Right,
Yeah,
so that
it's
should be the partial
of the f of y,
of the y component with respect to x
X
minus the
minus
partial of the
x component. with
x
respect to-
component with respect to y.
Yep.
Okay, so this one's the one that I'm going to need to pay attention for, right?
You should get.
You guys see that I really expect this to be the one that makes a difference anyway? Like, even if my intuition about paddle wheels is totally on point, they all point straight up. So this is going to be the only thing anyway. So, let's see.
You should do number 1 as a negative.
This guy, right,
Yeah.
is
We'll use the
some constant, and then your vectors are what?
let's see.
Minus y over x squared plus y squared, comma x over x squared plus y squared,
Yep.
comma 0. Okay, so the y component with respect to x,
So we have to use. Yeah, so it's.
yeah, we're going to have to use a quotient rule.
Yeah, quotient rule
Yeah.
is. I remember the quotient rule if you want to get.
2x times, no, that's not.
Yeah, it's
You don't have to use
the f. Prime.
Yeah, so you
F
don't
prime of
necessarily
x,
have to
GMX.
use the quotient rule, you can use the product rule too, right? You
I
guys
was
see that?
the question.
It doesn't matter, pick one.
I think it's usually best if you use a product if you have a negative.
Well, the one will just become 1.
They might make
I
this.
think it's pretty similar. to
Whatever.
that.
So, I'm putting a K here so I don't have to write the rest of this.
Okay.
And I should be getting what? How's the quotient rule work? You guys remember?
Quotient, it's f prime of x, g of x, minus f of x, g prime of x, all over g of x squared.
Yeah.
Okay, so take the derivative of the top, which is
1.
1, times the bottom, which
X
is
squared plus
x
y
squared plus y squared.
And then that's minus
And then you need to subtract x times
the
Yeah.
the derivative of the bottom, which is 2x,
x all over
x squared plus y squared squared.
Okay, and then we need to subtract, and here we should be doing the x component with respect to y, right?
Yep. So that's going to be a negative x squared plus y squared.
So we got a negative the quantity x squared plus y squared minus
Minus
Negative
y.
y times 2y.
plus y. Okay, so I made it a plus, and
Yep.
it's a y times a 2y,
Yep.
and it's all over
X squared plus y squared squared.
x squared plus y squared squared again.
Yep.
And really all I'm interested in is this stuff going to cancel, right?
Yep. It
And-
does. It does cancel out, doesn't it?
The first part does.
You get 2x squared plus 2y squared minus 2x squared, and
Oh,
then
shit.
minus a 2y squared.
Okay, so I got x squared plus y squared minus 2x squared plus x squared plus y squared
Then minus
minus
a 2y squared.
2y squared. Dude, cool.
Oh.
So that was there was a k there was a k here, and some crap on the bottom,
Yep.
and you get 0 k's, right? What the hell happened? Why did my intuition betray me? So I got a curl of 0, right?
Yep.
Where's all this spinning?
Outside.
Outside.
Outside of the what?
Boundary.
No. Outside of the.
String.
It's outside of the domain. You guys see that? The spot that it's spinning around, right,
Oh my gosh, it can't reach 0, 0, 0, so.
is on the axis. You guys see that? So your pinwheel, right, the pinwheel that we were putting in there, where does it go?
Outside of the domain.
Oh. Right? The only spot where there's actually spinning around, like everywhere else is just kind of moving, right? But the spot where they're spinning isn't in the domain anyway. So what did I get? I got the curl as 0, right?
Zero vector, but yeah.
So what the hell? You guys see this? Like, there's something fundamentally wrong. So let me think. What are they asking next? Does B satisfy the curl test? Does this satisfy the curl test?
No,
Why not?
there's an axis missing from the domain.
Yeah. You could put a zip tie around the x-axis, or around the z-axis, right?
Yeah, take it off.
Like specifically, here's the zip tie. Right? Are you going to be able to get that off of the z-axis? No. So this thing doesn't satisfy the hypotheses of the curl test. And so, what?
It's not a gradient field.
Yeah, even though the curl is 0, this is not a gradient field. You guys with me on that?
So if we don't satisfy even doing the curl test, then we're for sure not a
Well, okay. Let me see. So the way we have the curl test phrased, we wrote, if the hypotheses are satisfied, then it's a gradient field. So what I'm getting out of this is, I don't think it's a gradient field.
Is it like a contrapositive or something?
Yeah, so what I'm saying by saying, bad wording, the conclusion I should be drawing is that this thing is not necessarily a gradient field. You guys see that? It is actually true that this is not a gradient field. You guys see that?
Okay.
But the curl test as phrased just says, this thing failed the curl test, so I don't automatically know that this is a gradient field. You guys see that?
You have gradient fields that don't satisfy the curl hypothesis.
Yeah, that's not actually true. The curl test is actually if and only if, but
That's what I was just asking.
yeah. So this thing's not a gradient field. But the way I phrased the curl test, we don't necessarily know that. Cool? Questions, Seal?